Hello everyone. Today we will be learning about the wave function and Heisenberg's uncertainty principle. Be sure to watch the previous videos to gain a better understanding of what we will be talking about today. Last lesson, we talked about how particles and waves are related. This lesson, we will talk about the wave function and Heisenberg's uncertainty principle. To understand the wave function, we will look back at our water example. The water has peaks where it rises and places where it falls, and it repeats for a virtually infinite amount of times. In math, there is a function that can model this. It is called the sine wave. Let's take a look at the sine wave. The sine wave helps us model a wave mathematically. The equation for a sine wave is sine of x. This simple equation helps us model how waves move. It helps to predict the probability of a wave being in a certain place with a certain speed. The wave function is a description of a wave and what it's doing. Finding the location of waves isn't as straightforward as with particles. Let's think of our water example again. If we were to think about one band of water or one wave of water, how could we create an exact location for the entire wave? The wave function tells us where the wave is or might be. This is the wave function of a certain wave. Based on this graph, we can see that the wave has a higher probability of being here and a lower probability of being there. But in other cases, the same isn't true. Let's look at this wave function. It shows that a particle has an equal probability of being here and also there. The thing is that we can't see waves acting as waves because when we do, their wave function collapses. This creates a paradox. Let's look at a very famous example of this paradox, Schrodinger's cat. The cat is put in a box. The box has a very dangerous poison which might or might not be released. So how can one know if the cat is dead or alive? It is both dead and alive in this situation, and there is an equal probability for each event. It is not until that we open the box that we can see really if it's dead or alive. The action of opening the box collapses the wave function or the probability wave. The wave would then have a definite state and turn into a particle. The act of looking at the wave turns the wave into a particle and collapses its wave function. To date, nobody has ever observed a wave function. The wave function is a very important part of the wave. It shows the position of the wave and also the speed. Along with this, we can also see the wave function's wavelength. This helps us find the momentum and position of the wave. Squaring the wave function shows us the probability distribution of where the wave could be, and the position is given by the number of higher points and lower points in the graph. If the wavelength of a wave is like a sine wave and it has the same wavelength throughout the wave function, then there is a probability for the wave to be anywhere in the universe. If the wave function has only one value, then we know the position, but it is impossible to know the momentum. This is Heisenberg's uncertainty principle, and it stops us from knowing everything about a wave. That's about it for this lesson. Trying to wrap your head around something being in two places at the same time is a really confusing thought. If you don't understand, maybe you could watch this video again. Quantum physics is confusing, but it starts to make sense if you think about it. Thanks for watching.